and welcome to this learning webinar from Turning Data into Wisdom. The topic today is demystifying data literacy, understanding what it really means and why it matters. The learning objectives for this session are to define data literacy and recognize its importance in both personal and organizational decision-making in today's data-driven world. To understand the key data literacy competencies for data consumers or business users. To identify common misconceptions and challenges and barriers that stop people from either believing in, adopting, or using data literacy. To recognize the levels of data literacy for data consumers or business users and the importance of related soft skills. So we'll start by trying to define data literacy, and this is one of the challenges we face from time to time. Everything on the screen here is a different definition of data literacy that we found through web searching, Google, or whatnot, and they're all different, similar but different. The ability to read, work with, argue with data, the ability to understand and use data, the abilities to reason with problems, formulate and answer questions, collect, manage, and evaluate and apply data. Well, they're all similar. They all are a couple things. They're different and they aren't exactly clear. There's vagueness. So if you sit back and say, okay, I see the definition of data literacy is the ability to read, work with, and argue with data, I think a lot of people understand the data literacy is a term that's used. They hear that it's important. They might even understand and can recite the definition. But if it's that one, do you know what it means to read data? Do you know what it means to work with data? Do you know what it means to argue potentially with data? These are one of the reasons I think it's confusing for people, because that's somewhat subjective, but it's also not clear enough. So what we're going to try to do in this presentation is help understand what data literacy really is. Then we'll come back to the definitions and offer our own definition at the end. There's also a lot of misconceptions out there about data literacy, which leads us down the path of sometimes why it's not adopted a lot or why it's just misunderstood. So the first one is there's a lot of people that say data literacy is just another buzzword, probably because it's been promoted widely over the past decade or so, especially by tech companies, software companies, consulting firms. So while it's true, it's been kind of a trendy term lately, it doesn't diminish its importance. Data literacy is a fundamental skill in the world we live in today. And it's essential not just for data professionals, but it's actually essential for everyone. It's a life skill. So the next misconception is it's a lot of times mentioned or perceived that it's only for IT professionals or data analysts. This is a significant misunderstanding because it really should be part of everyone's skill set, from marketing to sales to human resources to everyone in the organization and everyone in the world. It's really about making better decisions through a better understanding of data, which is something that everyone can benefit from. Many times when companies or corporations or consulting firms talk about data literacy, they're talking about tools and they're focusing on the tool and not the thinking. So a tool sometimes is essential for getting your job done, and especially when it comes to data. But the core of data literacy is not learning a tool. It's learning critical thinking about data. It's about asking the right questions. It's about interpreting the insights and the results and making better informed decisions based off of that. It's not about knowing how to use a specific software tool or visualization tool. There's also vagueness, as we just talked about, with the lack of an objective definition. Going back to that slide we just had, it's hard for someone to say, okay, I know what it means to argue with data or to work with data. Without a clear definition, it's challenging to implement training programs, because what are we building the training on, or even awareness programs. And then the last misconception is that data literacy is binary, meaning either you have it or you don't. This oversimplifies data literacy. It is not that you're data literate or you're data illiterate. It is not binary. It is actually a spectrum of skills and mindsets and techniques that we'll talk about. It encompasses that wide range of abilities, from basic understanding of data concepts to more advanced comprehension skills. And it's not about reaching that final state and then you're data literate. It's really about continuous improvement and adapting these skills over time. Everyone's going to have a starting point, and a different starting point probably, but through those experiences and through that learning, they can enhance their proficiency. So data literacy is not binary, yes or no. So we've given you some definitions which are still vague. We've talked about some misconceptions. Now I want to pivot and say, okay, well, there are buzzwords, right? Why are there buzzwords? What is the value of data literacy to an individual or to an organization? So what you see on the screen are a couple quotes from different reports, analysts, consulting firms, and so forth that all talk about one of the reasons that organizations are doing better in a general sense is because of data literacy and making better decisions with data. So a study from the European Union's Joint Research Center found data literacy as a crucial skill for all citizens to participate in the digital economy, not just IT people, not just technical people. A report by Gardner suggests that organizations need to invest in data literacy programs to help develop their skills, their employee skills, and get them ready for today's digitized world. A study by the IDC found that data literacy is critical for professionals in all industries as the decision making becomes less hierarchical and top down and more widespread. Forbes magazine recently published an article highlighting the importance of data literacy for professionals as a tool for driving better informed decisions. A joint report by Click and Accenture found that data literacy is crucial for companies to succeed in today's world and landscape. And employees with stronger data literacy skills, again, not binary, are more productive and more innovative. And finally, a report from Deloitte found that data literacy is one of the top skills employers are seeking in their new hires when they're doing hiring and looking at candidates. So we've talked about why it's important, but does that move the needle? What can we quantify this? So now let's take a look at another slide that shows us maybe some quantification. And we're not going to read through all the studies here, but they're done through Accenture, PwC, IDC, Harvard Business Review, McKinsey. And there's a common theme around here. Organizations are more productive. Individuals are more productive. Organizations have higher returns. So Accenture says data-informed organizations are 23 times more likely to acquire customers and 19 times more likely to be profitable than ones that are not. PwC found the companies that make decisions based off of data, which again is part of data literacy, are on average 5% more productive and 6% more profitable. HBR, Harvard Business Review, similarly said 5 to 6% higher productivity, but also 4 to 6% higher profit margins. From an individual, the IDC actually said workers that are skilled in data literacy can earn on average $15,000 more per year than those that don't. So it is a valuable tool. It's not a buzzword. It's for everyone. It is not a technical tool. But still, there's confusion over what it is and what it isn't, and how do you become more data literate and what do you learn. So that's what we want to kind of address next. But before we get into that, it's important, I think, to demystify one of the words in data literacy, and that's the word data. I think part of the reason there's a confusion is because we don't understand when we say data, there's a preconceived notion that we're talking about numbers and spreadsheets and math and statistics. And we are, but it's not just that. So before we move on, I kind of want to level set and talk about kind of the transformative spectrum that data goes on, from raw data all the way to what I call wisdom, so turning data into wisdom. And so if we look at this spectrum, there's 5 different types of content that are stored in our brain: data, information, knowledge, understanding, and wisdom. And as you go up that level, the next level up is incredibly and exponentially more valuable than the lower level. So 1 ounce of knowledge is better than 10 ounces of information because we're getting it closer to where we need it. So when I think of data, I'm thinking of these different categories here and where does it fall into it. Starting with the lowest level data, which could be raw facts and figures, but it's not just numbers. It could be text and images. They're collected through observations, measurements, research, anything coming in through the senses at its lowest level is data. It could be a interview that is all qualitative, but it's data. Then we move on to information, where we start connecting those data points and potentially identifying patterns, and we're building kind of a preliminary insight. So this is processed data. Many times you'll see it from a quantitative point of view, you'll see it as aggregated data. So instead of a specific sales transaction, it's like, what's the average sales transaction, or what's the total? Many times it's just going to be those types of aggregations, but it's starting to show us patterns and trends and give us a little bit more context. But then we move into knowledge. In knowledge, where we recognize the value in that information, what it means to me, and we start relating it to all of my existing knowledge I have as a domain expert in whatever the field is. So we have those insights and we're starting to contextualize them. Are they relevant for the question, and so forth? From knowledge, we then move to understanding. So I kind of think of knowledge and understanding as book smart versus street smart. Knowledge is book smart. I know dates and facts and figures. A history buff or enthusiast, they've memorized dates, they've memorized names and events. That's knowledge. Understanding is being able to do something with that. So if that same historian was asked about things like social and economical or cultural factors that led to significant events during those periods, they might struggle to provide meaningful insights because their knowledge is limited to facts and figures, not a comprehensive understanding of the context and the underlying cause. So that's understanding, is when you start taking the knowledge and applying the context of the questions being asked, and then apply that to your personal belief system and your experiences and so forth. So at this level, you're comprehending insights. And then we move to wisdom, which is evaluated understanding. Here we apply the decision from the knowledge and the information we have and the understanding. We reflect upon it, we learn from it, and we adjust accordingly. And the action here is we're making data-informed decisions. So as we go through this process and we start looking at data literacy, I'm going to refer back to this because I'm going to say, at this point, we just have information. We don't have understanding. And as we go up each level from data to information, information to knowledge, knowledge to understanding, it gets harder and harder to avoid misinterpretation. Learning the skills to move up the value chain are not technical skills. They're not math. They're not numbers. They're, going from data information, we have to describe data. And that's one of the things we'll learn in one of those competencies. Going from knowledge to understanding, we look at things that help us reason with the data and say, okay, I understand what it's telling me, but now let's apply this to the situation we're in, the context we're in, and reason with it. Does it make sense for us? And then finally, going from understanding to wisdom, we're making informed decisions. So we're going to revisit all of this as we go through the presentation and tie certain things back to the data level or the knowledge level or the understanding level and so forth. But let's just take a look at a very high level example here. So let's say I'm working in a company and I'm in the marketing department, and my question that I want to look at is, how do I improve my marketing campaigns? So I start thinking about, what data do I have that I can use to help me answer that? So I look at the data and I have things like website analytics, social media metrics, email, marketing data, sales data. I have all this raw data. But then the raw data is not that useful because I don't necessarily care who visited my website at 10:52 p.m. on a Tuesday on a given week. I need to move it to information. So I need to see things like who are the top performing marketing channels based off of lead generation and conversion rates as the success criteria. What was the cost per acquisition of each marketing campaign? That's a higher level value to me than just the raw data. And so I have those answers, but those still don't tell me how I can improve my marketing campaign. I then have to take that information and apply it to my knowledge. I am in the marketing department. Part of my domain knowledge is understanding that certain marketing messages might resonate better. And potentially one of the things I've learned over the years is that if you integrate education content into the marketing, you're going to have better conversion rates. I don't know that if I'm not in marketing, and that might not be a true story because I'm not in marketing, but that's where you start taking the information and applying it to your business domain. And that's why data literacy is for everyone, but certainly I can't answer questions for a department that I'm not in because I don't have those years of experience. That's where the knowledge comes in. But just having the knowledge, we need to say, is that knowledge applicable to this question and this situation? And is it relevant? So this is where I integrate all of the insights with my strategic understanding of the problem, the question, and the context. And then finally, I'm going to make an action. So I'm going to say, okay, this is what's going on. This is my insight I learned. I validated the insight. Now from that, we're going to take an action to improve them. Taking that action, we learn from it. Did the action work? If it worked, that's my wisdom. If it didn't work, why didn't it work? And then there was something missing in our mental model of the knowledge and understanding. We go back and revisit it. And that's where we're updating our wisdom. So the goal in data literacy, if I could summarize it to one phrase, is we're always trying to go from data to wisdom with everything we're doing. And doing that is not requiring us to use statistics or math or anything. I mean, some of the math we'll learn that the basics is like a denominator. If you can do a denominator, you're good. It's about challenging the data, questioning the data, understanding the context. And that's how we go through these levels. So to do that, there's various competencies that we've set up for data literacy, because again, it's not binary and it's hard to learn a skill like data literacy if we don't break it down into smaller, more manageable chunks. So we've broken it down into 9 competencies that you'll see on the screen. Achieving a data mindset. So you have to have the belief and the mindset that data's around everywhere and it's useful for us and we can make better decisions. As you'll see through the presentation, one of the key skills we're going to learn, data literacy, if I could say what's the most important thing, it's questioning. Questioning the insights to make sure we have the right insights. We're not misinterpreting. We're not being misinformed. So one of the foundational competencies is data-enabled questioning, being able to formulate very objective, Socratic-like questions to make sure we're not being misinformed. But then we get into the crux of it. We have to be able to describe data. This is the data to information. What does it mean if I say the average salary is 50,000 US dollars versus saying the mode is 50,000 US dollars? What does it mean if I say my average sales are 1,200? Like describing what you see from the data and insights. Then we have some more advanced competencies, which might not be for the typical business user. They're more for the IT roles. Like there's one for collecting and gathering data, cleaning and processing data, doing the actual analysis on the data to come up with the insights. But then you get to the point where you have your insight. Someone else technical might come up with those insights for you. You're at the point where now we need to reason with it. So I understand how the data is being described, but now I need to reason it. Is that relevant for my question? Is that relevant for the context that we're in? And we'll see some examples of this. So in this place, we critically evaluate the data visualizations, the representations, and our conclusions. A big part of data literacy is not just validating those insights, but it's sharing those with others. So there is a big component of this where we're communicating those insights and data out to others. And then finally and lastly, we're using all of this stuff. Why do we want to be more data alert? Because we want to make better data-informed decisions. Decisions that blend the data components we're talking about with the human perspective to make sure we're challenging assumptions and we're mitigating bias and so forth. So these are the 9 high-level data competencies. But don't freak out, there's a lot there. But for most of us that are not technical or not in IT, Many of these don't apply. So I think that's one of the first takeaways is there's different roles to this. Not data literacy is not the same for every role. So we've organized these into 5 roles. Data producers that are generating the data engineers that are working on kind of the data pipeline from raw to ready, the data analysts that are trying to find those insights in the data scientists, which are doing a little bit of all of that, plus potentially doing some higher order advanced analytics and statistical modeling, and then data consumers, which is everyone else. We're not coming up with the insights, we're validating the insights. We're not doing any analysis in terms of quantitative analysis, but we're validating the insights, making sure they're valid, relevant for the question at hand. So when we just look at that role, the data consumer, which I think is everyone in the world, these are the 6 competencies that are relevant. So the first 2 are foundational, and we'll talk about that in a second, achieving a data mindset and data questioning. But the ability to describe data, the ability to reason with data, the ability to communicate with data, and the ability to use data to make better data-informed decisions are the 4 things that we want people who are data literate to do. And to do that, foundationally, you need to have a data mindset, belief in the power of data for helping you make decisions, and you need to be able to basically ask questions of data. So that's it for the data consumer, but then again, if you're interested in seeing what the pathways and the competencies are for data producers, data engineers, data analysts, we have these on the slide here as well. And we're not going to cover this deep. This is in another presentation, which is the data literacy competency blueprint. We have all of the sub-competencies that go under those, and they're at different levels. So the light blue is basic, the darker blue is intermediate, and then the darker of the blues is advanced, because it's not binary, it is role-based, and it is a journey. So you start at the basic and you move forward. But again, we're not going to focus on these. If you're interested in this more, go read our book on the data literacy blueprint or similar. So we've talked about data literacy and we've broken down those competencies, but still, can we go back and answer the definition? What does it mean to be data literate? What do we have to do? I don't think it's sufficient to someone to say, okay, well, I describe data, I reason with data, I use data to make decisions. We have to go a little bit deeper. So what are those skills that we need to look at? And I'm going to skip the first 2 for a second because they're foundational. But with describing data, we need to understand data fundamentals like mean, median, mode, basic descriptive statistics that would describe the data for us, being able to interpret a basic data visualization, knowledge about populations and sampling. All of these things kind of fall under describing data. And we're going to come back to these because I'm going to give you a couple examples where it's very easy to misinterpret describing data and reasoning data if we don't have this skill set. And this skill set, again, is not a technical skill set. So moving on to reasoning with data, this skill set's designed to kind of, if I put it in one category, enhance our analytical thinking. This is where we go from knowledge to understanding. It's avoiding logical fallacies, recognizing there's bias, understanding and using critical thinking with data by asking questions, being able to interpret statistics. So if someone comes to you and says, we've done this study and we see that there's a 90% practical, statistical significant difference with a margin of error of 5%. You need to be able to interpret that. You don't have to go and do the analysis, but you have to know what that means in the context to your question, problem, decision to make. And in doing that, that includes the concepts of things like probability and chance and uncertainty. Again, none of this is statistical learning. It's learning how to interpret things. Then we have the communicating with data. So how do we create visualizations to share them with others? How do we design them using things like Gestalt principle and pre-attentive attributes? And how do we take people on a story and communicate with them a narrative in a visual that's engaging, memorable, and persuasive? And then finally, how do we make better data-informed decisions? This is where we add in things like, is it ethical to use this data? Are we thinking systemically? Are we looking at different KPIs? So these would be the skills that you would learn in those learning paths to go from the basic, intermediate, advanced at the high level. The blueprint goes a little bit deeper. So I think we're getting better at getting closer to that question of what is data literacy and what do I need to be more data literate. But I still think it's kind of, it's hard without seeing some examples in action. So we're going to move to those in a second. But first, I kind of want to do an analogy. I think everyone understands what reading comprehension is. And I think that's one of the challenges with data literacy is people are like, well, if there's reading literacy is reading books, like we're not saying someone's data illiterate, but if you go with me, I think this analogy kind of makes sense. So if you're talking about reading comprehension at a high level, there's 4 different categories. There's the literal, which is just the basics. It's a literal understanding about identifying facts and details in a story. What happened? How many people? Similar to data literacy, we're just identifying the data, the facts, the figures, the words, and so forth. But then we have inferential reading comprehension. And this is a little bit deeper level. This is in reading comprehension. It allows us to interpret the information and infer the meaning from the author. Authors that do a good job at this is they don't explicitly tell you everything. You have to infer things. And that's what you're doing there is you're using inferential learning. The author gives you the context and the clues. Well, sometimes in data literacy, there isn't a context or clue. It's the number 12. And it's hard then to work backwards and try to infer from that what it means because we don't have the same context all of the time. Sometimes we just see a visualization. So then we move to like the evaluative step of reading comprehension. And this is where we go from not just inferring meaning, but we're now forming our own judgments. So it prompts us to think about kind of effects and hypothetical scenarios like what would happen if this, what would happen if that. And then finally we have the applied level where we apply all of this to our previous knowledge and understanding and personal experiences. And we can ask questions where we start applying it to new questions like what other possible alternatives are there? Do we agree with what happened here? Is this logical? So if I summarize reading comprehension, it's literal is what is the text saying? Inferential is what does it mean? Evaluative is what does it mean to me? And then applied is what does it mean in relation to the decision to be made? So now let's add data literacy on top of this. And with data literacy, I'm just going to summarize it and say there's 3 steps. These are the 3 steps we saw going up the data, information, knowledge, understanding, wisdom hierarchy. And we start with describing data. That's what happened. It's very similar to the literal understanding. We then move up to reasoning, which is very similar to the inferential thinking. It's interpret the information and what does it start to mean? Can I explain it? Can I explain the patterns and the relationships? Can I diagnose why did this happen? What can we predict from this? And then the making informed decisions kind of goes at the top level of both the evaluative and the applied together, where we're now making decisions and sound judgments on problems based off of the fact that we've reasoned with the data because we've been able to describe the data. So it's a spectrum. You might have some people that can describe the data and that's it. You might have some people that can start inferring things from the data, but the holy grail here is to use all of this to make better data-informed decisions. So if that's the case, and that's the goal, why is this a buzzword the past 5 years or so, or a decade? What's different now than, let's say, 20 years ago? Why is this not a buzzword from 20 years ago? Well, there's a lot of things driving demand now that's different. And we'll explore those. So first, there's more and more data that's generated and stored. We didn't have this problem decades ago. The sheer volume of data from social media interactions and transactions and sensors and IoT, it's a huge opportunity to get value from that, but there's also challenges with this. There's an increase in using data in decision-making processes. More and more people are making strategic decisions because of the data, which is great, but if they don't understand the data and they're only using a portion of the data, maybe a portion that aligns with their beliefs, but they're ignoring other parts, then we're not moving the needle forward. We're actually moving the needle backwards. We also have the rise of AI and machine learning and other things, and this is rapidly transforming industries because it's able to do things that humans are not, like analyze large, vast data sets very fast, very accurately. We just can't match that. But then we need to interpret the results. We need to make sure the results are not ethical, are ethical. It is important now to still use those human skills. Technology is changing faster than ever. It's an unprecedented rate. The exponential growth of technology and what we can do faster, better is exponentially growing. All of our tools and techniques are trying to keep up and they're becoming more sophisticated. But staying data literate in today's world means keeping up with all of this to remain effective and irrelevant. And we didn't have this rapid pace decades ago. And then last, and certainly not least, because of all those things, the spread of misinformation, whether it's deliberate or not deliberate, it doesn't matter, is all over the place. It's hard to go on a news channel or a website or an article or social media where there's not misinformation spread that says it's backed by data, but in reality it's not, because they're missing that inferential piece. They're missing the context. They're taking one piece of the data puzzle. They're not taking everything. Whereas in a book, the author is leading you down a path and they do it really well. They give you all that context where you can make inferences. Sometimes we get a piece of the data puzzle without that context, and it leads us down a path which is completely wrong. And that's why it's really important now to learn these skills so that we can avoid misunderstanding and decrease the spread of misinformation. So that's why it's important now. Now, before we get into some examples, let's say, okay, this should be great. What challenges, what blockers, what gets in the way from doing these types of things? And they're not technical challenges. It's not like I don't have a PhD in analytics or data science. They're all human level things. For example, I could spend all the time analyzing an insight and coming up and validating it, but I might have asked the wrong question. Many situations, people do all of the analysis and the interpretation correct, but they're answering the wrong question because we haven't well defined the question yet. We haven't built a data question. We ask a business question. Sometimes we're just working with incorrect data. Data might be incorrect for a variety of reasons. It might be outdated. It might be data from 2 years ago that's not longer relevant. Maybe it wasn't collected accurately. Maybe it was a survey that wasn't done the right way. Or maybe it's it's incomplete. Much of it is because many of us lack describing data, fundamentals of data. Why is it important to know the central tendency, mean, median, mode, things that we learned in potentially, primary school math? What else gets in the way is misleading visualizations. It's hard not to see a visualization lately every day that leads you in your brain toward a conclusion that's not accurate because it's, again, intentionally or not intentionally misleading. A lot of times we talk a lot about there's more data, but there's also more complexity in the data, which means a lot of times there's a hidden relationship. So we're thinking problem A caused problem B, but in reality, it's not that simple. It's probably problem A with a little bit of C, D, E, F, G, and H collectively caused us to have problem B. And understanding those hidden relationships, especially if they're not in the insight or shared with you, makes it hard. We all have fallacies and bias. We have whole courses on our website about these. The brain is great. It's a powerful supercomputer, but it is victim to bias and logical fallacies. And one of the things that we have to do in data literacy is by thinking critically, we overcome those fallacies, we identify them, and we mitigate the biases. So one of the common biases, as an example, is confirmation bias. You have an opinion. The brain is going to select what it's paying attention to by finding stuff that agrees with your opinion. It's not intentional. It's not done maliciously. It's not like you're sitting there consciously saying, I'm going to ignore these things. It's all done subconsciously. Many times we might do all that stuff right, but we had the wrong assumption about the problem set. Maybe we've had an implicit assumption that we didn't state explicitly that caused us to go sideways. Maybe it's because of how the world worked in our long-term memory has changed and we didn't recognize it's changed. And then finally, you could do everything right, but if you don't communicate it the right way with your stakeholders, it's going to be a huge blocker. So all of these things are going against us. On top of that, there's two overarching themes: that we're human, so that means we're emotional, and many of us have overconfidence. We don't realize we have bias, so we're like, oh, it wouldn't happen to me. And all of these things can also cloud our judgment, lead to irrational decisions where we think they're rational, but they're not. So all of this stuff can get in our way. Learning those data literacy skills of describing data, reasoning with data, is going to help us overcome these. So now we're at the point where I've done a lot of talking and I've mentioned what it is, why we need it in the categories, but I think we need to have some visual examples that kind of bring this home. So what I want to do is talk about those different categories, like describing data and reasoning with data, and give you a couple examples of why that's important. So let's start by examining, let's say we're working marketing, we're looking at some initial data from two marketing campaigns. We'll just call them A and B. And the question is, which marketing campaign was more effective? So you see in the bar chart on the screen, it's showing the number of impressions of each of the two campaigns and how many they generated. Campaign A generated roughly around 500,000 impressions, while campaign B generated around 350,000 impressions. Now, if I'm a stakeholder, or maybe not in the marketing group or whatever, and I look at this, I might conclude that campaign A was more successful in engaging the audience. However, in marketing, I might say, okay, well, impressions are only part of the story. They reflect the reach, but not the effectiveness. And my question was the effectiveness. But again, if I see this, reading a book, the author's taking us down a path where we can infer things. There's nothing being taken down this path. It's a visualization in isolation. The context that we have is the title. So I look at words, effective. What does it mean to be effective? If I don't understand marketing campaigns, I'm going to say it's campaign A, right? But let's go to the next slide and let's put another chart next to it. So in this other chart, we're looking at the click-through rate, the CTR by campaign. And when we add this into this, what we actually see is despite the lower impressions, campaign B had a click-through rate of 3%, resulting in a little over 10,000 clicks, 10,500. And campaign A's click-through rate was 2%, which resulted in less clicks. It was only about 10,000. So what this shows me with more context is that although campaign A had more impressions, campaign B was more effective at engaging those that saw the ads because they have a higher click-through rate. So when we add the click-through rate in our review, our conclusion shifts. This kind of highlights the importance of looking beyond initial impressions. Even though we can describe data on the first chart, yep, campaign A greater than campaign B, but that doesn't mean it answered the question that was being asked, which is effective. What is more effective? So in this case, by considering additional relevant metrics like click-through rate, we potentially avoid the premature conclusions that we see here. And this highlights where knowledge comes in that data, information, knowledge, understanding, wisdom spectrum is if I'm in marketing, I have the knowledge that maybe CTR is the right variable to use. One of the things when we talk about asking the right questions, we don't ever want to be in a situation where we ask a question to two or more people and we get a different answer. That's horrible. So one of the goals with data literacy and talking about asking the right data questions is you can ask it to anyone on the data team or IT, or it's specific and clear enough, you're going to get the same answer. Which was more effective might not be the most descriptive title, depending on your stakeholders listening to this, because they might not be in marketing, they might not know these things. So that's where the knowledge comes in. But it's not just about knowledge. So let's take another example here where I show the number of unemployed workers in two regions, Region A and Region B. And so someone in our team builds this chart and they see that there's 850 unemployed in Region A and there's 570 in Region B. And we want to we work for the city or the state or whatever, the county, and we want to build a program to help decrease unemployment, but we have to pilot it first. So we have to pick a region. and the analytics team and the data team builds this slide and shares it with the stakeholders. This is the data in context, the data puzzle. The title right there, unemployment is more prevalent in region A. How could you argue, right? 850 is greater than 570. Makes total sense. 100% makes total sense. But what if I show a different visualization with the same data? So now what if I go in and I'm starting to question the underlying context? I might ask, what's the population of each region? So if I ask the population of each region, I say, show me a percentage. So region A had 3,500 people. Region B had a little over 1,000 people. So when we say words like prevalence, unemployment is more prevalent in region A, based off the second visualization, that is not a true statement. There's a higher percentage of people that are unemployed in region B. Now, again, it all goes back to what's the question, what are you trying to do? Eventually, what's the budget? Is it people or percent? But the point is, we see a visualization, our brain tells us a story. I don't need to know anything about marketing knowledge in this example. What I need to know from data literacy is when we see raw values, we want to know what the population is. We want to know what the denominator is. When we see the flip and we just see percentages, we still want to know what the population is. So these are things you learn to describe the data. If I see raw data, I want to ask for the denominator. So those are examples of describing data. Let's take a look at now moving up to that reasoning with data. And there's a couple examples here. So in this case, let's talk about an organization, and they conducted a study to find effective ways to boost revenue. They discovered that employees who receive a 10% performance bonus saw a 20% increase in revenue. So from this data, they gain the knowledge, again, going data, information, knowledge, understanding is revenue increase was double the bonus expense, suggesting a strong return on investment. 20% is greater than 10%. That's knowledge 101. So let's move up the value to the understanding now. From data, information, knowledge, understanding, a bonus structure will motivate employees and will increase our revenue output. So then we make our data-informed decision based off of our reasoning is we're going to roll out a 10% bonus structure to all employees. Sounds rational, but it might not be. For example, how many people in that study were given a 10% bonus? If it was 2 people, is that enough of a sample size? Like, all of those things are not statistics or analytics. It's us questioning the data. It's us asking the author to give us more context. And sometimes we don't get more context because we don't have access to the author, but then we have to think critically and make decisions on this. So we can describe the data, 20% is greater than 10, but to reason it, we have to say, okay, in what situation could this not be the right decision? Well, what if the survey only had 2 people? How did you pick those 2 people? As an example. Let's look at another example of a coffee retailer, and they want to understand market preferences to inform their expansion strategy. So they conducted a study and found that 20% of people in region A and 70% of people in region B like coffee. So the knowledge here is straightforward. 70% is higher than 20%. Let's go to our inference, and our understanding is region, we might say in this case that region B has stronger market potential for coffee products. Sounds true, sounds plausible, sounds practical. So what's our decision? Well, let's focus marketing on region A. But again, here, what we might not have done is, do we know how many, in this case, do we know how many people were studied? How many people are in those regions? Knowing the denominators, knowing the populations are useful for that. So what we do in these cases is we don't just go with the decision, we question them. Now, reasoning with data doesn't just have to be words and numbers like this. It can be visuals too. So here's an actual visual from the BBC near the time when the COVID outbreak came out. And what we see on the screen is, let's read the title. It says, coronavirus cases increasing in European countries in recent weeks. So the bottom axis, the horizontal axis, is dates from January 1st to September 1st. I think it was 2019. And then the vertical axis is showing cases per 100,000 people. So when it says 150, it's 150 of 100,000 people. So like one exponentially by 100,000. And what it shows is it shows 5 countries: Spain, France, UK, Italy, and Germany. And we see roughly where I drew the horizontal line near the end of July, we see all of them going up higher. And it looks a little flatter for Italy and Germany because they're smaller samples. But if we showed them on different scales, they're all going up. So let's go through data, information, knowledge, understanding, wisdom. That's our information. What's our knowledge taking away from this is coronavirus went from roughly 10 cases per 100,000 people in Spain on July 1st to 125 cases per 100,000 people in Spain on September 1st. 125 cases per 100,000 is bigger than 10 cases per 100,000. So what's our understanding is coronavirus is more prevalent since the end of July. Plausible scenario. It makes total sense. Nothing in this visualization would lead me otherwise. And this is where knowledge comes in, because in the early days of coronavirus, we didn't know a lot about it. So we didn't know you could walk around and still have it but be asymptomatic, but you could still transfer it to others. We also did things differently. We didn't test everyone in the beginning. We tested first responders, elderly, things like that. So in reality, let's look at the next chart here, but let's add some annotations on this. So now I've added some annotations that says, okay, what's different? Well, we tested around that vertical line near August 1st, we changed our testing strategy. Before that, it was symptomatic, elderly, first responders. We know now, our knowledge is that you can be asymptomatic but still have it. So everyone wanted to get back to work. So near the end of August, these 5 countries changed their testing strategy to test everyone. So let's go back to the data, information, knowledge, understanding, wisdom. Yes, same knowledge. Coronavirus cases went from 10 cases per 100,000 to 125 cases in Spain. Questions that I'd ask. The title says coronavirus cases. How are we defining a case? Let's use some existing domain knowledge we just learned. Coronavirus is sometimes asymptomatic. So we can't say these are all the cases. What we can say is these are people that tested positive. All I can say from this slide is that on end of July, we changed our population, we changed our testing strategy, and we're testing more people. This tells me absolutely nothing about the prevalence of coronavirus. Now, it very might be more prevalent, but this chart is showing me we have more cases because we're testing more people. It has nothing to do about the infectiousness. So as we learned more throughout the pandemic, you'll notice a lot of these charts started changing. They were using things like percent positive or things like that when we learned more. But that's a case where everyone was drawing information in fear and paranoia, when in reality, this chart it's technically accurate, so you describe it correctly, but reasoning with it, we have to say, okay, well, this isn't telling me the story. This is telling me cases went up because something happened earlier that changed the testing strategy. That is data literacy. That is questioning so we don't misunderstand things. It's not about us building analytics or similar. It's just questioning. So let's look at a couple more examples of reasoning, and then we'll move on. So in this example here, what I'm doing is I'm showing, for a recent marketing campaign, I'm showing sales revenue from January to August. And I'm highlighting an annotation that we launched a new marketing campaign in June. And what I'm showing is the insights on the right. Sales have jumped at least 20K a month as a result of a marketing campaign. Does this validate the marketing campaign led to more sales? Well, potentially, but it might not, right? I mean, it could have been something else doing it, but a lot of times we see this, the brain has this thing that says the make sense mandate. Does it make sense? Yeah, more marketing leads to more sales. It makes sense. So we might not question it. And for those of you that questioned it, kudos. Let's use the same data and we'll just change the variables. So in July, we started marketing more ice cream and people were eating more ice cream. And we noticed that shark attacks jumped 20% a month after that. So your brain, now we say, okay, does that mean that ice cream sales is leading to more shark attacks? Is the answer that we stop selling ice cream? No. none of us would have knowledge of shark attacks would think that, because the brain's like, that doesn't make sense. But a lot of times in data, the variables make sense, marketing, sales. So the brain goes along with it, but we don't stop and say, what else could be causing it? That is what we're doing when we're reasoning with data. We're pausing and saying, are there hidden variables? Is there something else could have caused this? Is this correlated but is not causation? None of these things require statistics or analytics. It's critical thinking, and those are the skills you learn in this section. So now we're going to move on to an example of communicating with data, because I mentioned it's great to be able to describe data and reason with data, but we also need to be able to communicate with it. So here I'm going to show you two stories, kind of a before and an after. And you tell me which one's clearer and more engaging and easy. And sometimes the problem with communicating with data is people think just because we have data, we have to share it, and we throw too much data in there. There's a science to storytelling. So here's the visual, and I'll tell you the story. So today, we're going to review our extensive employee retention data across multiple dimensions. We pulled together a comprehensive set of analytics for this. As you can see here, the retention rates are broken down by department, job grade, and tenure. Each department's further subdivided into categories based off age, gender, and even the type of employment contract. Additionally, we've overlaid this data with our regional economic indicators and industry benchmarks to give you a multi-dimensional perspective. Now, please direct your attention to the complex scatter plots and heat maps showing correlating employee satisfaction scores with their likelihood of staying at the company. Now, these graphs do use advanced statistical models, including multiple regression analysis and variance calculations. And this is critical to understanding their nuances of affecting employee retention. You'll notice some pivot table and cross tabular data there. This is comparing quarterly retention trends against historical data going back 5 years. So I hope this gives you a sense of the breadth of data we're considering in our efforts to address employee retention. That is a dense communication with too much data, not understanding your stakeholders, but someone who is data literate might have the same stakeholders and the same decision to share, and their communication might look something more like this. Over the past fiscal year, our company's employee retention has dropped 5%, as you can see in the bar chart on the left. Maintaining a high retention rate is crucial for minimizing recruitment costs and maintaining team stability, which impacts overall productivity and profitability. Now, we've conducted exit interviews and analyzed employee engagement surveys and reviewed HR policies and benefits packages, and the data indicates that employees with a lower engagement in things like team activities and company initiatives are more likely to leave. In fact, you can see in the bar chart on the right, based off of high, medium, and low engagement, their probability of leaving. So this decrease in retention rate that we're trying to get is a critical issue for us. It impacts our operational continuity, and it can potentially lead to increased hiring costs and reduced productivity. So our goal is to improve retention, so we should enhance our focus on fostering a supportive and engaging workplace culture and provide targeted support and recognition. By enhancing our engagement and support, we aim to improve our retention rate, contributing to the company's operational efficiency and financial health. Now, albeit that's not perfect, that is a better communication using data and storytelling to the stakeholders than the ones that had the dense visuals and the complicated story. That is what we teach in communicating with data. So as we get toward the ends here, we're just going to go back to these competencies that we talked about before for the consumers and highlight that we talked about describing data, reasoning with data, communicating with data, making data-informed decisions. And then the drivers for these, the foundational ones, are the achieving a data mindset. You have to have the belief and the mindset that data is going to help you. You also have to learn how to do questioning and critical thinking, and that's the data-enabled questioning techniques. Now, data literacy, as it's starting to come more in focus, it is a combination, but there's a lot of soft skills that helps us. In fact, more soft skills than technical skills. So I'm not going to read through them here, but we put them in 3 different categories. Helping you understand complex situations, helping you collaborate and communicate, and helping you adapt to change. All of these soft skills here help you with better data interpretation, better decision making, ultimately better data literacy. So when we talk about teaching data literacy competencies, a lot of times we're infusing these skills into them as well. So let's now go back to that slide from the beginning that talked about the challenges and the misconceptions and the myths of data literacy. And let's break them down a little bit more here. Data literacy now, I think we can tell, is not a buzzword. It's data's everywhere. There's all these misinformations. It's essential for what we do. It's not just technical. It's universal. It's not using a tool. It's understanding basic concepts like denominators and critical thinking and asking the right questions. So it's universal for everyone. It's not just technical, and it's not just learning a tool. It's learning critical thinking and communicating. It is not just for accountants and data people. It is broadly applicable to everyone. And finally, it's not binary. It's not yes or no, you're literate or you're illiterate. There's actually a continuum where you can go across from the basics of data literacy to mastering it over time. In fact, that's what we're going to show you on the next slide is our 4 levels of data literacy mastery, starting with data awareness. And this is where you're at the level of more like describing data. You can recognize and recall basic concepts and terminology. You can understand the relevance of data and decision making. And so things you need to know is you need to know basic mean, median, mode, understanding different visualization types, different classifications of data. Then we move to level 2, which is data understanding. And these skills are where you can interpret visualizations, look for patterns and trends, and start understanding the context. So things for these would be like explaining the meaning of data presented in a graph, like we showed in those examples, or summarizing trends. Then we move to level 3, where we're going to like the reasoning with data. So it's applying different interpretation techniques, asking critical questions, using data to support decision making, seeing if there's biases within any of the insights or challenging assumptions. And then we move to, okay, you're using all this to make informed decisions. We're assessing the quality of the data and the relevance, we're validating the insights, and we're coming up with a decision. So with all of these things put together, I'd like to propose a new definition that is the ability to understand, interpret, critically evaluate, and effectively communicate data in the context to inform decisions and drive action. And then additionally say it encompasses the skills necessary to transform raw data into meaningful wisdom and insights and apply these within real-world situations. So we use the word understand, a foundational comprehension of data concepts. We use the word interpret, focusing on making sense and extracting meaning. We use the word critically evaluate to highlight the importance of questioning and assessing data quality and relevance and sources. And then we use the phrase effectively communicate, which emphasizes the ability to convey data insights clearly and persuasively to others. So hopefully this gave you a better understanding of what data literacy is. To learn more, take a look at our website, turningdataintowisdom.com. We have educational content broken out into data literacy, data-informed decision-making, data strategy, AI, all those data-related soft skills we talked about, and a monthly series called Becoming a Better Data Citizen. And the content's broken out into articles, videos, white papers. We have some tools, we have assessments, we have podcasts. We have our own data literacy GPT where you can ask it a question specific to data literacy, and it's got a vast knowledge base of data literacy specific content. And then we offer different offerings from free membership access to the articles to individual subscriptions to team and organizational subscriptions. Our goal there is to empower data literacy for everyone, one decision at a time. Check it out at turningdataintowisdom.com. Hopefully you found this valuable and have a better understanding. We've accomplished our goal of demystifying data literacy. Thank you for listening.